The concept of force in magnetic field has a rich history, intertwined with the exploration of magnetism and electromagnetism. The study of magnetism dates back to ancient civilizations, such as Greeks, Chinese, and Indians, who discovered naturally occurring magnetic minerals like lodestone. These minerals were observed to attract iron and other magnetic materials, indicating the existence of magnetic forces. In the 17th century, scientists like William Gilbert made significant contributions to the understanding of magnetism. Gilbert's work laid the groundwork for modern magnetic theory, describing the Earth as a giant magnet with magnetic poles. In the early 19th century, Henry Mary Ampere formulated Ampere's law, which relates the magnetic field produced by a current carrying conductor to the current's strength and direction. This law provided a mathematical framework for understanding magnetic forces due to electric currents. In the 1820s, Michael Faraday conducted groundbreaking experiments that demonstrated the interaction between electricity and magnetism. He discovered that a current carrying wire produces a magnetic field around it, and a magnet moving near a conductor induces an electric current. Later, these experiments transformed into electromagnetic theories. James Clerk Maxwell unified electricity and magnetism in the 1860s with his set of equations known as Maxwell's equations. These equations described how electric and magnetic field interact and propagate through space, providing a comprehensive theory of electromagnetism. In the late 19th century, Hendrik Lorentz formulated the Lorentz force law, which describes the force experienced by a charged particle moving through a magnetic field. The force is perpendicular to both the particle's velocity and the magnetic field direction. In the early 20th century, quantum mechanics revolutionized our understanding of microscopic phenomena, including magnetic forces. Quantum mechanics introduced the concept of spin, which is associated with intrinsic magnetic moments in particles like electrons. Today, the understanding of force in magnetic fields underpins various technologies and applications, including electric motors, generators, magnetic resonance imaging, particle accelerators, magnetic levitation trains, and magnetic confinement fusion reactors. Researchers continue to explore magnetic forces in novel materials and applications, driving innovation in science and technology. Force in a magnetic field refers to the influence exerted on a charged particle or a current carrying conductor when it interacts with a magnetic field. This force arises due to the motion of charged particles and their interaction with the magnetic field lines. The force experienced by a charged particle moving through a magnetic field is described by the Lorentz force law. According to this law, the magnetic force on a charged particle moving with some velocity in a magnetic field is equal to the cross product of velocity and magnetic field times charges on the particle. According to the right-hand rule, the direction of force is perpendicular to both the direction of particle's velocity and the direction of magnetic field lines. The very significant nature of force in magnetic field found its place in daily life of human beings. Here, we are mentioning only three of those applications. Electric motors. Electric motors rely on the forces exerted by magnetic field to convert electrical energy into mechanical energy. When current flows through a wire in the presence of magnetic field, a force is exerted on the wire, causing it to move. Magnetic separation. Magnetic separation is a technique used in various industries to separate magnetic materials from non-magnetic materials. For example, in mining and recycling, magnetic separators are used to extract ferrous material from waste streams. Magnetic door locks. Magnetic door locks, also known as electromagnetic lock, uses magnetic field to secure doors in buildings and facilities. These applications highlight the general use of magnetic forces in day-to-day life, demonstrating the importance of magnetic field interaction in the society. Apart from these, forces in magnetic field have a diverse range of applications in various industries and technology. You can check out our blogs for further readings about it. As this force gained popularity in human society, it attracted curious minds and multiple questions to itself. Here, we are mentioning three of them. How does the force in a magnetic field affect charged particles? Charged particles experience a force when they move through a magnetic field. This force acts perpendicular to both the magnetic field direction and the particle's velocity. What determines the strength of the force in a magnetic field? The strength of the force in a magnetic field depends on the magnitude of the magnetic field, the magnitude of charge of the particle, and the velocity of the particle. What is the difference between the force in a magnetic field and the force in an electric field? The force in a magnetic field acts only on moving charged particles, while the force in an electric field acts on both moving and stationary charged particles. Here we have discussed only three applications and FAQs, but in our blog, we have extended the list for you. You must check that out. Link is in the description. We have additional contents, further readings, and transcript of every episode.